Okay, the rest of this section deals with combination of tan and secant. And again, even though it's tan and secant, it applies to cotan and cosecant. Just remember there's a negative whenever you take a derivative and so on and so forth. So if I look at those, and this is provided on the exam, I will give you a formula sheet. You will find it in Blackboard, and I'll show you that at the very beginning of class. First day, you could print that and have it next to you and use it on every test. This is one of the formulas provided. If I look at a tangent and secant, if I see that the tangent is odd, I save a secant tangent. Remember, that's your du. What do you take a derivative to get secant tangent? Secant, obviously. And if you see an even secant power, you save a secant squared, which is du. What do you let u equal to get? So what do you take a derivative of to get secant squared? It's the tangent. When I glance at this, so the good news, the odd goes with tangent and the even goes with secant, and that's why I really don't want you to memorize this. It's kind of annoying. But if you see both of those m and n being odd or even, you know the rule applies. The only time this rule would not apply, if you look at a tangent that has an even power and a secant that has an odd power, then you should really revert back, convert everything to sines and cosines, and proceed that way. So when I look at number 36, for example, and I notice they're both odd, I have this table next to me, and the formula sheet will provide it literally the way I see it. So make sure you're looking at this as you're doing the homework. Again, you'll have that from day one next to you. So since it is odd, I'm going to apply this rule. So save a secant tangent. If I save a secant of x, tangent of x dx, what would be left? Wouldn't I still have a secant squared of x and a tangent squared of x? Now, this is my du. I'm thinking ahead of time. What do you let u equal to get a secant tangent? Derivative of secant. So this secant is okay. That's not a problem. This tangent I need to eliminate, because if I let u equal secant, this would become my du, and there's my u really, right? So what do I know about tangent squared? Again, you go back to the original right there. I know tan squared is secant squared minus 1. That is secant squared of x minus 1. And now if I make my substitution, now if I let u equal the secant of x, du will be secant of x tan of x dx. So if I let u equal this secant right here, du is right there. This will be the integral of, this is u squared, this is u squared minus 1, and that's simply du. That easy. And wouldn't this be u to the 4th minus u squared? So wouldn't that be u to the 4th minus u squared? So that's u to the 5th over 5 minus u cubed over 3 plus c. And wouldn't that be, again, my u, remember my u was secant, wouldn't that be the secant to the 5th of x over 5 minus the secant cubed of x over 3 plus c? And that would be my final answer. That simple if I know this rule. And let me look at another problem. I have a couple more to go. And if I notice they're both even, again, I know the rule applies. I'm going to follow this trend. So I'm going to save a secant squared. Well, hey, that's a secant squared. That's the whole thing, okay? Not to worry. What do you take a derivative of? So again, I'm thinking this is my du. What do you take a derivative of to get secant squared? Tangent. So I really don't have to do much work on this problem. All what I have to do, choose u, and du is right there automatic. If I let u equal tangent of x, du will be secant squared of x dx. There it is. This would become the integral, and let's see, u and du, oops, the color didn't match. Here we go. If I let u equal tangent, this will be u to the fourth, and du is simply right there. So this is u to the fifth over 5 plus c, and that's really the tangent to the fifth of x over 5 plus c. And this rule is really straightforward and simple. There's not much to it. Let me get the next problem. Next problem up. Again, I'm looking at this, saying, okay, well, okay, I see a secant. It is even. Okay, but secant to the fourth. So I'll take the 2 out. And according to the rule, if I follow the trend, I need to save a secant squared of 2x dx. Remember, this is my du, which means the other secant squared I can't have. What does secant squared equal? Tangent squared of 2x plus 1. Again, make sure you have the identity handy. And now, if I let u equal tan of x, du would be right in front of me off by a constant. So if I let u equal the tangent of 2x, there it is. So far, this is the integral of u squared plus 1. Du would be, and let's see how that works. Du would be secant squared. Let me write it this way, it's easier. It'll be 2 times secant squared of 2x dx. So when I really want to write what secant squared equal, it's really 1/2 du. And there it is. Simply u cubed plus u plus c. And I do recall what u was. U was the tangent cubed of 2x plus the tangent of 2x plus c. That would be my, how come I don't start using this all along? It'll make it look a lot nicer, right? You guys should tell me something.